Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise. We're going to find equations of tangent lines. And this question, in fact, was deeply handled in Calculus 1. In fact, this was one of the most important themes of Calculus 1, which is finding finding an equation of tangent line to the curve at the given point. But this time, the story is a little bit different because we are given the curves in parametric form. So essentially, and the point that we're looking for, the tangent line, is not provided to us because the curve defined by the parameter t, like in the first case, self-intersects itself. Okay, so that's a very interesting situation because there's no way to have a self-intersecting curve defined in Calc 1 and defined as a function. But here we are okay because we are using the parametric form, and the curves might intersect themselves at certain locations, and they may do it like several times, which is okay. And without giving you more heads up, I want to show you what you're going to get into. As you see that in the first case, the curve intersects itself at t equals -1, and we're going to sort of like try to determine that by looking at the graph. So it's very important to be able to know how to graph those with your graphing calculator. And in the second one, we also have another self-intersection going on here, and we will try to come up with the equations of tangent lines at that point, because we may have two different tangent lines, because the graph goes, let's say, like moves on the trajectory of the curve and comes back to that point for a different t value. So that means you should expect a different tangent line popping at the same point. Okay, as I said, I do not have the intention to give you the heads up because I want you to watch the video and then see the details in the video. So let's get started.
All right, let's look at part A. We have x equals t squared minus t, and we have y equals t cubed minus 3t minus 1. First of all, since we're going to write down the tangent lines at the point where the curve crosses itself, so we have to find out where, at what point, or at what t the curve crosses itself. To be able to see that, you should be able to graph the parametric equations first, because it's very hard, by looking at this description here, it's very hard to see where it crosses itself. Okay, so what you can do now, you can pause the video and graph t squared minus t for x and t cubed minus 3t minus 1 for y, and get like enough range for the values of t, maybe a large range of the values of t, okay, to see where the curve is crossing itself, okay? And I had that also done here, and I can show you that the curve, if you follow the orientation and everything, so the curve goes in this direction, okay, and then makes a turn here and then crosses itself, okay. So and the crossing occurs at 2, 1, okay, the point 2 and 1, okay, and you can sort of like guess that from the plot of your TI-84, and you can just zoom in completely and then grab that point to be like 2 and 1. So that's not enough, because that means x equals 2, y equals 1. I still don't know for what t this happens, right? For what t value this happens. So what I'm going to do next here is that, since this is happening at 2, 1, so let me just write that down here, crossing itself. The curve crossing itself, right? We have the point 2, 1 that where the curve crosses itself. So what I'm going to do next is to find the t value, spitting out x equals 2 and y equals 1. So I'm going to solve t squared minus t equals 2 and t cubed minus 3t minus 1 equals 1. Okay? So now you have a system of equations to solve. And you can pause the video at this moment and then try exploring how you can attack solving these two equations for t. And I'm going to show you my way, and yours could be totally different from this. What I'm going to do is adding these two equations. Okay, so t cubed plus t squared minus 4t minus 1 equals 3. And I'm going to subtract 3 from both sides. Okay, so t cubed plus t squared minus 4t minus 4 equals 0. So once you have a cubic, one of the ways to find one of the roots is just trial error. Okay, so I'm going to sort of like plug in sample t-values and see if I can nail one root. Because if you can do that, then you can, that means you can have one factor of the cubic, so you can rely on to the polynomial division, which is the part probably you should do by yourself. But let's first find a zero of this equation by, for example, choosing t to be 1. Let's see if t equals 1 solves it. So 1 plus 1 minus 4, that's not equal to 0. So t equals 1 is not a good choice. How about t equals 0? Well, that's negative 4 is not equal to 0. That's not a good choice either. As you see, I'm choosing like sample t-values and simple t-values, but simple t-values in the meantime, okay? So t equals negative 1, so you have negative 1. Let's see, negative 1 plus 1 plus 4, negative 4. Here we go. We got this equal to 0, okay? So t equals negative 1 is a good choice, and that means t plus 1 divides the cubic. All right, so go ahead and pause the video, because this is the part I'm not going to do, because this is sort of like algebra. Have the long division. Divide this polynomial t cubed plus t squared minus 4t minus 4 by t plus 1 and get the quadratic out of that. And that quadratic is going to tell you the other roots, other zeros of this equation. Okay? Please do it. All right, here we go. If you have the long division, you should be able to get t squared minus 4 coming out of that. And if you factored it out more, it's t plus 2t minus 2. And from this analysis, we have t equals negative 1, 2, and negative 2. So we, in fact, have 3 different points. So, but if you look at the curve here, this should happen only at 2 t values. So you got to be careful here and find the right 2 of those candidates for t. Okay, so let's check for t equals negative 1. For t equals negative 1, I got negative 1 squared minus 1. That x equals 2. And if you plug in negative 1 for y, let's see, negative 1 cubed plus 3 minus 1. That takes you to 1. Okay, so t equals negative 1 is the right point because I end up being at 2 and 1. Okay, how about t equals 2? For t equals 2, x is going to be 2 squared minus 2. That's 2. And y is 2 cubed minus 3 times 2 minus 1. And that takes you to 1. Okay, so you can just convince yourself. Okay, you can pause the video anytime, by the way, and convince yourself. For t equals negative 2, what do we have? X equals negative 2 squared minus 2. Here we go. You got 6 for x. So this t is a pathological t coming out of solving these two equations. So this is not a good choice of t for this purpose. Okay? All right, good. So we have 2 different t values, and we're going to find the equation of the tangent lines over there. So I don't need this anymore. So I'm going to get rid of that because we have already found the t values for the curve to cross itself. And I'm gonna find the dy over dx at those points because I need the slope. Okay, for dy over dx. We have this trick of dividing top and the bottom by dt, all right, so that we can individually differentiate y and x. So you have 3t squared minus 3 at the top and 2t minus 1 in the bottom, okay? And I'm going to evaluate dy over dx at two different t values. So let me call this to be m1 for the slope corresponding to t equals -1, and m2 for t equals -2. For m1, let's see what we have. T equals -1, so it's 3 times -1 squared. I'm just plugging that back in here, so for your reference. T equals -1, so this is completely 0 because the top becomes 0. Okay? And for m2, this is t equals 2k's. 2 squared equals 4. 4 times 3 equals 12. So the top is 9. And the bottom is 2 times 2 minus 1. That is 3. So the second slope has to be 3. All right, we have two tangent lines at the same point. So tangent line 1, tangent line 2. For the first one, it's pretty easy because m1 is 0. This is a horizontal tangent line. So that is, in fact, y equals 1. Okay, that's pretty straightforward. And the second one, I'm going to use the slope, point slope form of the tangent line. So y minus the y coordinate of the point equals the slope times x minus the x entry of the point. So y minus 1 equals 3 times x minus 2. Okay, so now I can go back to my original graph and verify that I have one horizontal tangent line and another one with positive slope. Okay, let me just clean this up. As you see, I have one horizontal tangent line, which is the dashed line here, and I also have a tangent line, as you see, with a positive slope. Okay, this is visually me convincing myself that you have two different t values corresponding to self-intersection, t equals -1 and t equals 2, and you've got the tangent lines for those points. All right, so I think we're done with part A, and this is already a long video. Please continue to the next video to see what I'm going to do for part B. All right, thanks for watching. Bye.